Okay then. Uh, so am I audible and my screen is visible? So yes, no. Sushmita.
Yes, sir.
So am I audible?
Yes, sir.
Okay, my screen is visible.
Yes, sir.
Thank you. Okay, we were about to discuss real-time communication over packet-based network. So most oftenly, whatever you are studying in your CCNC, rate control, quality of service, so shortest path, routing, service disciplines. Maybe the terminologies are almost similar, or maybe a bit different as such, but we are discussing the same stuff as such. So there are two disciplines through which the package-based service discipline is maintained as such. So one is work conserving discipline, then other one is non-work conserving discipline. So he has used a short forms whenever you encounter in the following slides. Just make sure that WCD and NWCD. That's how he mentions it. A server is never kept idle if there is a packet to be sent. So it's some kind of greedy approach. As and when the packet arrives at the server, it is best effort is made of the almost ensure that it puts it onto the one of the other channel. If the outgoing link is busy, then packet is good. Otherwise, it is put onto the traffic. So no traffic shipping is achieved because there is a bit giving whenever you say then the packet is good. So there is a buffer, but burst and other kinds are not discussed as such. So with respect to work conserving disciplines, there are some algorithms discussed. Again, WFQ or weighted fair queue, multi-level, first come first service queue, or delay earlier due date. So these are some protocols that are discussed with respect to work conserving discipline. And similarly, non-work conservative is each packet is assigned an eligibility time. So whenever you arrive, so you will be taken up next, or you assign some time for that particular packet, and after this packet becomes eligible to be served with respect to the timestamp whatever that is put by the server, then it is going for the transmission. So therefore, an outgoing link can be idle. So whenever packet has arrived and the link is free, but it normally I say I will attend you after 5 minutes, or that's how the server decides. So in those kind of scenarios, the link may be unutilized or underutilized because you are not putting that packet onto that channel as it arrives. So there are reasons for that. So we'll look into that. Stated jitter. So the protocols associated with the NWCD or the non-work conservative discipline, jitter, EDD, earlier due date, stop and go, HRR, and rate control static protocols. So these are the some algorithms again discussed in the forthcoming slides as such. So comparison, the type of service discipline deployed affects delay, buffer requirements, delay, or jitter basically. So delay and buffer or memory intermediate nodes should have some memory, or the FIFO or queues, whatever that has to be implemented, and finally jitter. WCD needs lesser buffer, as the name suggests. WCD or work conservative discipline puts any packet that comes to it almost instantly if the link is free. If at all the link is not free or it is having a traffic, then only it goes to the queue. So and hence it needs a lesser buffer and causes shorter delay than the NWCD. NWCD is having some reservation so that it doesn't immediately allocate you the channel. So there is some waiting period every packet has to undergo. So it's somewhat conservative in nature, and WCD cannot bound delay jitter tightly while NWCD can. So WCD, there are variations with respect to traffic, so how much every packet can go. So there can be lot many deviations with respect to expected arrival or exit of the packets as such. Um, Whereas the NWCD can make that jitters smaller. So if jitter is causing you the problem, or the network service of QoS jitter is a prominent element that has to be addressed, then you will go for the NWCD as such. Processing in a non-work conserving discipline, so there's a eligible computation time. So then whenever a packet arrives, So you put that time stamp to that particular packet. Whenever that becomes eligible, it goes to the multi-level queues and separate the packets and goes to the channel. So it goes through the channel in the wherever a particular destination is there, and that is demarked, and that will reach that particular destination. So multi-level first come first service queues. So it is used to implement static priority schedulers. So that means the nodes are assigned priorities. So each level of the queue corresponds to a different priority levels. So each connection is assigned a priority. Packets from that connections are inserted into corresponding FCFS queues. Multiple connections can be assigned to the same priority. So you can see that multiple queues also over here. So it is something similar to your OS queues. So there were some stuffs, so kernel level tasks and non-kernel level tasks, or the application level tasks and kernel level tasks. If you can recollect in the similar fashion, so there are multiple queues, and each queue has its own priorities. So kernel levels may be having the higher priority, and the application level tasks are having lesser priority. Similar to that, so whenever a packet arrives, it is checked appropriately and put into a particular queue. So and in the queue, it follows a FCFS, or first come first serve basis. So head of the node emptied on every clock cycle will be checked with respect to the whoever is eligible for the transmission, and he is made to transmit over the channel. So packets are scheduled in FCFS order from the highest priority to non-empty queue. The transmission restriction number of different delay bounds provide to the connections, bounded by the number of priority levels. So ultimately, how many priority levels also restrict in terms of the task scheduling. So whatever we had a restriction about the priorities, the similar restrictions will follow up in the multi-level FCFS queue as well. Next, weighted fair queue, or fluid fair queuing, which is the source for WFQ as such. Each connection sharing the same link. There is a separate FIFO queue. So during any time interval when there are exactly n non-empty queues. So again, there are multiple queues of the weighted fair queue. The server serves the n packets at the heads of the queues at the rate of 1 by nth of the link speed. So what you are maintaining is link speed. So 1 by nth of the link speed is to be achieved. So the FFQ allows different connections to have a different service shares. So that is, you are dividing by with respect to bandwidth kind of architectures. So characterization by n positive real numbers. So then there is a m set. So how much is allocated, and total the service rate of a non-empty queue is divided by this. So C is total link speed or total bandwidth. So proportion of which is allocated. So at that particular, how much speed is individual link is having is shown just over there. So fluidic fair queue FFQ serves packets in the non-empty queues according to their service shares. The server can serve all the connections with non-empty queues simultaneously. So because the links are separate, and it has to be, the traffic is infinitely divisible. It is almost says that it assumes a continuous kind of traffic, and hence fluidic fair queue or the FFQ is impractical. The continuous or infinite divisible shows that the fluidic or the continuity nature of that. So practically it is not feasible, and hence the people shifted for the weighted fair queue. So then there is a proportion of the weightage given for the with respect to link speed assertion. So then jitter, earliest due date. When a packet is served, the field in its header is stamped with the difference between its deadline and the actual finishing time. So how much time is having, so that he just makes it to the destinations is computed. So a regulator at the entrance of the next server holds the packet for this period. So before it's eligible to be scheduled, it provides delay jitter modes. So ultimately, you make sure that you deliver the packets at the promised instances. So that is what is important in what that non-conservative work disciplines, or NCD, whatever the short form comes out to be. So it provides jitter modes. So delay bound and pre-ahead. So there is a deadline, then the departure in the switch I. Whenever so I minus 1 to you are moving to I. So there is a holding, and then it becomes eligible with respect to the computed times. And ultimately you meet your deadline. So meeting deadline is fine, but jitter is basically avoiding that again, deviation with respect to the expected delays. So basically it is something similar to your Q factor with respect to the bandwidth as such. Okay then. Stop and go. This is based on multi-level framing strategy. Again, something similar. So one time slot delay is inserted. That's what is meant by stop and go. One level of framing. The time axis is divided into intervals of T called frames. So average aging interval. Each connection is allocated a bandwidth in a proportion to the certain fraction of the frame. So something similar to pi into fi by fj into whatever the pi j and mod is link speeds into cj. That's what we computed previously. So ultimately what it is doing is at each switch an arriving frame is mapped to a departing frame of the output link. So constant delay theta is introduced. So that means you are making it to wait for a particular duration. So a fixed duration called as a theta. The transmission packet that has arrived on any link during a frame F should be postponed until beginning of the next frame. So that a minimum waiting period is made sure. The server remains idle even if there are packets queued from the transmission. So whenever you arrive at a particular node, you have to stay at least for a theta duration, then only you can go further. Framing strategy introduces the delay of any packet at single switch is bounded by 2 frame times. So now you have that fixed durations or delay capacity. To reduce the delay, a smaller t is desired. So unnecessarily I'm wasting bandwidth. If that is a criteria comes to the designer's mind, then the T should be reduced. So the waiting period within a node without any transmissions. So once it arrives, to make sure that you reduce the T. Assuming the fixed packet size P, minimum granularity of the bandwidth. So with respect to the packet size and within which it is doing nothing or that waiting period. So that is granularity of bandwidth is P by T. So to have more flexibility in allocating bandwidth, smaller granularity, a large T is preferred. But whenever you prefer a large T, what happens? So you are violating. So you are most often you may be idling this stuff as such. Um, Therefore, low delay bound and fine granularity of the bandwidth allocation cannot be achieved simultaneously. Somewhere there's a trade-off, and that has to be bargained with respect to how much you can bargain with respect to quality of service factor as such. So multi-level framing in stop and go. The time axis is divided into a hierarchical framing structure. For n level of framing, suppose a frame size is T1. So there are sizes. TM for wherever level to multiple levels are there. So then packets on a level P connection to use frame size TP. So there are different framing strategies with respect to timing. That is what is being implemented in multi-level framing in stop and go protocol that is showcased in the slide. So at time T1 frame and the duration of the frame is different. So with respect to times as such. So T2 is 3 times the T1. That's ultimately the with respect to time the packet size will be different. So and that we go for a different waiting periods as is stop and wait go, stop and go. One more was rate control static priority drawbacks of previous service disciplines. Sorted priority services. So you want a sorted queue over there, such as a fair queue. So who has come first or the weighted fair queue, and difficult to implement. Framing strategy suffers from the dependency between the queuing delay and the granularity of the bandwidth. So that how much should be the packet size and what should be the waiting period if you are bargaining with that. That was the hurdle faced in the previous stuff. So in RS CP or rate control static protocol, the function of rate control has been decoupled from the delay control. So you look into the system design as a two separate aspects. One is the rate control, and another is the delay control. So in RSCP server has two components, rate controller and static periodic scheduler. So rate controller is oriented towards rate control the rate. It consists of a set of regulators for each connection. Each connection responsible for shaping the input of traffic into the desired pattern. So whether you want to have a CBR or VBR or whatever the amount of data you want to send with respect to the intervals, that will be decided by your rate controller. When packet arrives, its eligibility time is calculated and assigned to the packet. The packet is held at a uh, regulator, whether it is queued or buffered, until its eligibility time expires. It is then handed to the scheduler for scheduling the transmission. So again, multi-level FCFSQ is implemented server packets in the order of their priorities. So priorities may be with respect to their deadlines as such. They can be of two types: rate jitter, so variation in the rates, so how much can be sustained. It controls the rate jitter by partially reconstructing the traffic. So whenever I say reconstructing the traffic, so how do you manage your packet sizes? Delay jitter, so it controls delay jitter by fully reconstructing the traffic. So um, fully basically you decide upon the packet and as well as the t aspect of the timing aspect of that. So how much it has to wait in a queue as such. So regulated traffic and multiple levels, the queues regulator 1 2 3 and priority levels 1 to n, and hence you are able to achieve the stuff as such. Previously also we discussed about internet protocol and end server and differential servers. So we discussed something like RS reservation protocol, RSVP. So that there is a tree or minimum spanning tree, and the source initiates transmission. So initiate means whoever wants the data will initiate a request. So then there's a path message and a reservation message, and then the message transmission happens, and so on. So that was with respect to the same TCP/IP, or the internet has to support both kinds of traffic, and RSVP was one of the protocol discussed with respect to the real-time traffic management over the internet. So what it guarantees to guarantees the QoS assurance to internet-based applications. Sorry, several models have been proposed by IETF. So one agency. Three major QoS models have been proposed. So integrated services, differential services, and multi-protocol label switching (MPLS). So IntServe, designed to be common platform for both real-time and non-real-time traffic, can extend internet protocols such as IP as per flow-based QoS form with a dynamic resource reservation using RSVP protocol. So there is a RSVP protocol previously discussed, comes in the integrated services mechanism. So what is integrated? So you are accommodating both kinds of traffic. One is internet normal traffic, and another one is the real-time traffic. Okay. So or synchronous and asynchronous kind of traffic that was discussed whenever we discussing those terminologies as such. Again, includes two types of services targeted towards real-time traffic that is guaranteed. These services provide an upper bound on end-to-end queuing delay. So delays becomes more predictable and suitable for the real-time applications as such. So this model aims to support hard real-time requirements. Predictive, these provide statistical guarantees only. So predictive is it's more predictable, but on the internet it's a runtime environment. There can be several other parameters will affect the speed or the collision or the other factors. So predictive comes with respect to whenever you are dealing with any computer architectures, your past is deciding somewhere your future. So some algorithm starts predicting or this packet will go into or will be delivered. So that happens, but again, as stated, it is predictive. It may not happen as such. So the amount of state of information increases proportionally with the number of flows, places. So huge overhead on storage, processing on routers, because whenever you are entering into the non-real-time and real-time mixture, then there is a buffering required. Even if it is a non-real-time, then you want to transmit it later. That has to be buffered in that particular node as such. So overhead of storage and processing on the routers. Also have to implement RSVP, so bandwidth reservation, so that there is a normally we assume that network service provider has provided the minimum spanning tree whatever is required for the framework required for that real-time implementation of network, and reservation are to be made by the communicators. So basically whoever is demanding the resources will establish a reservation of the path nodes. So there is only one request link from the lower nodes, and multicasting from the upper nodes or root node to the several leaf nodes. So there is a multicasting that is happening. So that process involves some communications, again some computation with respect to nodes as such. So ubiquitous deployment of int services required for guaranteed service. Incremental deployment of int services difficult. So you have to think holistically and then make it happen. That's what is stated over. The differential services overcomes the limitations of int services where you are combining both kind of services together. So it is simpler and more scalable. It redefines types of services filled in the header IPv4 and IPv6 traffic bits. So this first 6 bits are called DS code points or DSCP. The information buffer management and scheduling is carried out within the packets. Special signaling protocols are not required for the differential server, whereas it was required by the RSAP or the real-time communications. The amount of state of information maintained per node is proportional to the number of service classes. So there are different class of services, and the amount of information every node is holding is almost directly proportional to the service classes, not of the number of application flows. Application flows are not discussed over there. He has unnecessarily introduced that terminology, I feel so. So diff service is based on the important design principle. It tries to push complex processing associated with the QoS provisioning to the network boundary. So there is some negotiation or some transactions happening with respect to reservation kind of stuff that is avoided. Network boundary means application hosts and edge routers. Since network boundary system handle only small amount of flow, so they are ideal suited for perform complex tasks such as packet classification, traffic conditioning as compared to the core routers. So it is as good as you are making smaller groups and then connecting them, or something like a tree structure has been constructed even in the diff server. So provides two service models. One is a premium service. It is guaranteed peak rates, service optimized for regular traffic patterns. In most, there are no queuing delays. Virtual lease lines, so that a particular bandwidth is reserved for one or the other user as such. Assured service, so it provides statistical guarantees to the application. So whatever you are running will run smoothly, will not suffer any repercussions in the runtime that is promised. So soft real-time communications in LAN, characteristics of LAN are no absolute QoS guarantees are provided to the applications. So you can run the applications, but normally it is normal internet. Best effort is made so that the packet has been transmitted, and with whatever the network parameters, bandwidth, jitter, delay, propagation delay, and so on. So all are kept well within the restrictions. If anything best can be provided, that will be provided, but not guaranteed. Only ensures prioritized treatment for the real-time messages. The pass by lane, so jumping of the lane is provided. So helps that jumping helps the message deadlines to miss the ratio minimum. Provides statistical guarantees to the delay bounds. So statistical is the pre-computed or history. So it's a predictive or the predictable kind of stuff, not guaranteed. So soft real-time communication LAN, both soft real-time and non-real-time messages can be transmitted. That is, asynchronous traffic can happen over there. Some assumptions: soft real-time traffic is generated by CBR and VBR, so constant bit rate or the variable bit rate sources. So whenever you know I'm uttering those terms, you should be able to imagine that. So what is it? Fixed data size and fixed intervals, and variable data size and variable intervals with respect to CBR and VBR traffics. Soft real-time messages rates are very low compared to the channel capacity, and that speaks about underutilization of the bandwidth. So both soft and non-real-time tasks may arrive periodically in bursts. So in presence of bursts, it is more difficult to sustain the guarantees to the soft real-time traffic. Um, because whenever you are say that sigma rho model or any other models, we was keeping that buffers, and there was a terminology called as a traffic shaping and policing. So rho is the bus size plus like sigma into t. So what is the average traffic plus the burst? So if there is a buffer to accommodate that, then maybe you are going for a traffic smoothing or shaping. So if you are discarding, you are making the transmitter retransmit, and the traffic policing happens over there. Smoothen effects of the bus that happens, that means there is sufficient buffering is there. ಅಂದ್ರೆ buffer ಇದ್ರೆ ಮಾತ್ರ ಅದು possible ಆಗ್ತದೆ. Fixed rate of traffic smoothing algorithm, it was developed by some persons, however you pronounce it, Quan or Chin. It takes into account limits of the transmission capacity of the network. There's input limit on each node between MAC and TCP/IP, and there is again token bucket that is incorporated or previously discussed with respect to traffic control algorithm as such. So every source will be able to transmit whenever it has the token allocated, and bucket will replenish the tokens with respect to fixed rate. So unless you have obtained token, you will not be able to transmit over the channel as such. That somewhere manages the traffic or traffic smoothing algorithm. So there is a leaky bucket algorithm similar to that. There is a token bucket algorithm, whatever we have discussed. The algorithm has two important parameters, CBD and refresh period. So CBD is constant bit rates. So that is a synchronous traffic that goes with respect to the stuff. Refresh period is with respect to token replacement as such. So new credits, the wordings are changed, but the concept remains same. The maximum number of credits that are added to the bucket on every refresh. So the maximum number of credits that our bucket can hold. So CBD, constant bit rate, replenish rate, or the refresh period. So with the fixed time or periodicity, the tokens are replenished. Stands for smoothing algorithm. It stands for the averaging guaranteed throughput for non-real-time messages. Stands current network share stands for the number of credits present in the bucket at any time. So in my case, or the what I feel is he's just again explaining the token bucket algorithm with different terminals as such. Nothing higher he is going for explanation as such. Okay, I think CNS message number of bytes, and there's a code, and hold message buffer until CNS is greater than 0. So that's how you achieve the whenever you have a token, then you only are able to transmit it. That he has written in the code manner or the pseudocode as such. The algorithm is not flexible. Once the delay requirements of the time are known, the network wide input limit is fixed. The transmission rate of the non-real-time sources reduces as a number of nodes increase on the LAN. So ultimately, when the nodes increase in the LAN, the bandwidth gets shared, and the data rate with which you are transmitting gets reduced, and hence more delays will be incorporated. Or that's how the system gets inflexible or not flexible as. The algorithm is pessimistic. It is based on the worst case calculations on the total real-time traffic. So basically, whenever you are planning for at what rate the token should be replenished, then you can answer better this question. So that there is a scope for handling the synchronous messages or CBR, whatever you want to attain the real-time traffic. So then the best effort for the asynchronous communications as such. So adaptive traffic scheduling, it was proposed by okay, tries to achieve better the non-real-time traffic adapted according to VBR. So now you are going for a variable bit rate. How he accommodates it. Okay. So detect the changes in network utilization, adapt to the transmission limits to the detect the change in the network utilization. So that's an NA layer or the network abstraction layer, which has a constant monitor over the network, and then change the parameters as per the network variations. So maybe the replenishment rate of the network of the tokens as such. Okay. The basic questions: how do you detect changes in network? The number of collisions per unit time is used as an approximate measure for the network utilization. So in case of collision, the credit bucket is immediately emptied except for the packets under transmission. So that ultimately, how do you replenish or so add or remove the tokens from the bucket? That is what is controlled whenever you are stating the traffic scheduling is adaptive. and with which you are able to achieve that CBR to VBR traffic. So how to adapt transmission limits to a detected change in the network utilization? The station input limit CBR divided by rate parameter, or the replenished rate, or refreshment period is adapted by the change in either CBD or RP. So if there are no recent collisions, then RP can be decreased. ಅದನ್ನೇ ಹೇಳ್ತಾ ಹೋಗ್ತದೆ. So just read it. I think a database we'll take up in the next class, and maybe another 2 or 3 classes I will finish the syllabus. So any doubts, please post it on to the classroom message. So these whatever the communication protocols after the exactly 802.4.5, those protocols are RSVP. So most of the stuffs are related to your CCN or computer communication networks theory as such, and hence you can refresh it faster. Maybe some terminals, conservative work discipline, non-conservative work discipline. ಈ ಥರ ವರ್ಡಿಂಗ್ಸ್ ಅಗೇನ್ ಯು ಹ್ಯಾವ್ ಟು ರೀಫ್ರೇಮ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಆರ್ಟೋಸ್. ಅದರ್ ದನ್ ದಟ್ the concept remains same. Okay. Okay, then I will take a leave. So any doubts, you are free to ask. Okay, you can leave the meet.